tree of heaven. It arrived in Philadelphia in 1784, brought by a gardener who wanted it for its ornamental appearance. It has been spreading ever since. Tree of heaven, known in botany as Ailanthus altissima, now grows in all 48 contiguous states. It covers an estimated 30 million acres of the eastern United States alone. It lines every major highway corridor on the East Coast. It grows in sidewalk cracks, in abandoned lots, in the foundations of buildings, and in forests where nothing else has broken through yet. The reason it spreads so effectively is not just that it grows fast, though a seedling can reach 8 feet in its first year. The reason is what it does to the soil around it. Its root system releases a chemical compound called allanthone. Allanthone is toxic to the seedlings of competing native plants. Before any other tree can establish in the same space, the tree of heaven has already poisoned the ground against it. A single tree produces over 300,000 seeds per year. Each seed can travel on the wind. There is no native insect, fungus, or animal in North America that controls its population the way predators and pathogens keep it in check in its home range in China. The U.S. Forest Service has listed it as one of the most ecologically damaging invasive species in the country. No large-scale removal effort has successfully cleared it from any significant area. Every year, the acreage it covers increases. It is not going anywhere. It got here first. Kudzu. The United States government paid farmers to plant this one. Kudzu was introduced at the 1876 Centennial Exposition in Philadelphia, presented by Japan as an ornamental vine. In the 1930s, the Soil Conservation Service began promoting it as an erosion control solution for degraded farmland across the American South. Farmers were paid up to $8 per acre to seed it. Over 100 million acres were planted across Alabama, Georgia, Mississippi, Tennessee, and the Carolinas. It grows 1 foot per day in summer heat. It does not stop at the field edge. It climbs trees, telephone poles, fence lines, abandoned structures, and anything else in its path, covering whatever is underneath completely and blocking all sunlight from reaching it. Trees under a kudzu canopy are alive when it arrives. They are dead within a few growing seasons. Nothing in North America eats it in meaningful quantities. No insect population controls it. No fungal pathogen has reduced it. In Japan and China, where it is native, biological checks exist. Here, they do not. It simply grows every spring from wherever it stopped the previous year. It now covers between 7 and 9 million acres across the American South. The government spent decades trying to remove what it spent decades planting. The removal programs have not kept pace. Japanese knotweed. In the United Kingdom, it is illegal to allow Japanese knotweed to spread from your property onto neighboring land. Mortgage lenders have denied home loans on properties where it is present. Disposing of it improperly is a criminal offense. It is classified as controlled waste. In the United States, it grows freely along roadsides, riverbanks, and property boundaries in 42 states. No equivalent federal restriction exists. Japanese knotweed was brought to North America in the late 1800s as an ornamental plant and livestock forage. Its hollow stems grow to 10 feet in a single season. Its underground root system extends 15 feet horizontally and 7 feet deep. Cutting the visible growth produces new stems from the roots within days. Herbicide application requires multiple consecutive seasons to reach the root depth where the plant stores its energy. A fragment of root the size of a fingernail left in disturbed soil will regenerate into a full plant. Construction projects move contaminated soil to new sites and establish new colonies at the destination. Flood events carry root fragments along river corridors and deposit them wherever the current slows. In the United Kingdom, where it arrived earlier and its economic impact has been more fully documented, the annual cost in property damage and removal is estimated at £1.5 billion per year. American estimates are smaller only because the full accounting has not been completed. Giant hogweed. In 2018, a teenager in Virginia used a weed trimmer to clear brush on his family's property. He did not recognize the plant he was cutting. The sap reached his skin. Hours later, after sunlight exposure, he had third-degree chemical burns across his face and arms. He spent weeks in hospital. The scarring was permanent. Giant hogweed was introduced to the United States in the early 1900s as an ornamental plant. It grows to 14 feet. Its flower clusters spread 2.5 feet across. Its hollow stems can reach 3 inches in diameter. It looks dramatic and unusual, which is why it was planted in gardens across the Northeast. The danger comes from compounds in the sap called furanocoumarins. These are photosensitizing agents. On unexposed skin, they cause little immediate reaction. When skin coated with the sap is then exposed to ultraviolet light, a chemical reaction destroys the tissue at the point of contact. The burn appears hours after exposure. Most people who are affected do not connect the injury to the plant contact that caused it. If the sap reaches the eyes before sun exposure, permanent blindness is possible. Kogon grass. Fire management in the American Southeast depends on the predictable behavior of native grasses. Controlled burns reduce fuel loads, maintain habitat, and prevent the kind of wildfire buildup that turns into catastrophic events. Land managers have used fire as a tool across Florida, Georgia, Alabama, and Mississippi for decades. Kogon grass has changed how fire behaves in every landscape it enters. It arrived in the United States in the early 1900s, carried in contaminated ballast soil on ships, and later deliberately planted in the 1940s for erosion control. It is now established across approximately 500,000 acres of the American South and expanding northward each decade. Kogon grass burns hotter than native grasses. It ignites more readily. It burns at temperatures high enough to kill the root systems of native species that would normally survive fire and regenerate from below ground. When fire moves through a Kogon grass infestation, the native plants do not come back. The Kogon grass does, and it expands into the burned area that native species can no longer recolonize. The fire that was used to manage the land now works in its favor. Water hyacinth. It was displayed at the 1884 World Cotton Centennial Exposition in New Orleans as an ornamental aquatic plant with large purple flowers. Visitors were given free samples to take home. Within a decade, it had closed navigable sections of the St. Johns River in Florida. Water hyacinth is the fastest-growing aquatic plant on Earth. Under warm conditions with sufficient nutrients, a single plant can double its mass in 2 weeks. It spreads across the surface of freshwater systems in dense floating mats that block sunlight from reaching aquatic plants below, deplete oxygen in the water as the biomass decomposes, and produce fish kills documented across Florida, Louisiana, and the Gulf Coast states. The mats block boat navigation. Municipal water intake systems that draw from infested rivers require constant mechanical clearing. Recreational use of affected waterways stops entirely in areas of heavy infestation. The purple flowers are still considered ornamental. It is still sold in some states as a decorative pond plant. The label does not mention the St. Johns River. Bufflegrass. The Sonoran Desert in southern Arizona did not burn. Not in any significant way, not for millions of years of its ecological history. The plants that evolved there evolved in an environment where fire almost never occurred, which means they evolved without any fire resistance at all. The saguaro cactus can live for 200 years and reach 40 feet. It has no defense against fire because it never needed one. Bufflegrass is a perennial grass native to Africa and the Middle East. It was introduced to the American Southwest in the 1930s and 1940s for erosion, control, and livestock forage. It grows between saguaros along roadsides, on rocky desert slopes, and in the dry washes that carry water only occasionally. In summer monsoon conditions, it produces enough continuous biomass to carry fire across terrain that never burned before. When that fire moves through a buffel grass-invaded section of Sonoran Desert, saguaros die, palo verde trees die, ocotillo dies. The native plant community that took centuries to establish burns in a single event. After the fire, buffel grass regrows from its roots. The native species do not. The desert that never burned is burning. The plant responsible was put there on purpose. Thanks for watching. If you made it this far, you already know what to do.